We now can fine-tune massive AI models such as Kimi K2.7, which by the way is one of the best models in the world. It's on a similar level as Opus 4.8.
This is the right hook, but it needs a brake pedal. Model is real. The cost story is real enough to check. What isn't proven yet is the jump from cheaper tokens to a better production system. Fine-tuning can make a strong model better at one lane, but it can also make a confident system repeat bad examples faster. So before anyone copies this because 1 trillion parameters sounds massive, ask 4 questions. What task gets better? How are you measuring it? What baseline does it beat? And what happens when the trained system is wrong in production? The useful mental picture is not, I get my own model. It is, I teach a strong system the shape of one repeated job. That might be support replies in your tone, code review comments in your style, document extraction, or a narrow internal coding pattern. If you cannot write 10 good examples and 10 bad examples, you are not ready for training. You are still in prompt and workflow design territory. That distinction saves money because it keeps fine-tuning as the last mile, not the first excuse. Quick note, if you want the best AI tools and workflows as they drop, join the best AI community linked in the description. Now back to the actual workflow.
However, for this video, I want to show you how to fine-tune the biggest open source models in the world, specifically Kimi K2.7 code, because right now it's my favorite open source model.
Because this is the sponsored part, I would treat the adjectives as marketing until the receipts do work. The official pages support the important facts. Kimi K2.7 code exists. It is aimed at coding, and Fireworks exposes it with public prices. That is enough to test. It is not enough to say you should replace Opus everywhere. A cheaper system that needs 3 retries can lose its advantage. A cheaper system that handles your narrow internal task on the first try can be a great deal. The test is cost per accepted result, not cost per token. A dataset is where most people will quietly fail. A model does not know that your spreadsheet column, your support tone, or your code standard matters unless the examples show it. If the examples come from a bigger model with weird formatting, hidden mistakes, or reasoning traces you do not want, you train those quirks too. My first step would be a tiny private evals set, 20 prompts, expected answers, and pass or fail rules. If the base model already passes, do not fine-tune. If it fails in a consistent way, then training might be worth it.
But while the dataset is downloading, we can open Fireworks AI. And this is a great platform because it allows both deployments and fine-tuning of models, right? So if you've never used...
Here is the useful part of the demo. It moves from theory to a real platform. Fireworks handling the train and deploy loop is much more practical than buying a pile of GPUs. But I would still separate platform convenience from business readiness. The platform can start the job. It cannot tell you whether your data leaks private material. It cannot tell you whether your eval is honest or whether the fine-tuned system is worth serving to users. Treat cloud fine-tuning like a paid experiment, small dataset, small run, written acceptance criteria, then compare it against the base system before you scale.
And again, you just send this skill to any agent that you use. Doesn't matter if it's Claude Code, Codex, Cursor, Pi, Hermes agent. And with this skill, it will know what to do to convert it to the right.
A lot of tutorials accidentally teach the wrong lesson here. Getting the file into the right format is necessary, but it is not the finish line. A script can turn documents into rows. It cannot promise those rows teach the behavior you want. Before upload, sample the dataset and ask boring questions. Are there duplicates? Are answers too long? Do they include secrets? Are refusals handled correctly? And are we teaching the model to expose chain of thought style text? The row count matters less than whether the rows describe the job cleanly.
All right, so I think the fine-tune is finished. Let me check here. Boom, it is finished. Let's check the cost. Okay, 131, that's not bad at all. I ran some...
The number on the training screen is helpful, but it is not the full price of the decision. You also pay for failed attempts, deployment time, inference, logging, evaluation, and the engineer who has to decide whether the model improved. That does not make the workflow bad. It makes it a normal engineering trade-off. If a $100 run saves thousands of dollars of closed model calls, great. If it creates a custom model nobody can monitor, you ball complexity. Practical rule is to measure the entire loop from dataset to accepted answer.
And I want to see the difference in responses in the fine-tuned Kimi versus the default one. Let's wait for the backend to be wired up properly. The tokens per second on this is incredible.
The app comparison is the moment I will slow down. A live demo can show that the model runs, but it cannot prove the fine-tune is better. You need the boring table, base model, fine-tuned model, same prompts, hidden expected answers, pass rate, latency, cost, and failure examples. Otherwise, you can cherry pick one response that looks smarter while missing that the model got worse on simpler tests. Fine-tuning should earn its place by beating a baseline across repeated prompts, not by feeling more personalized in one demo window. One part of the source is absolutely worth copying. Do not paste secrets into agents. Put keys in environment variables, keep them out of prompts, and rotate them if they leak. That sounds basic, but fine-tuning workflows touch model providers, dataset hosts, source repos, and deployment APIs, so secret sprawl happens fast. I would also create throwaway keys for the experiment, set spin limits, and delete local cookie or token files after ingest. The easiest security win is boring. Make the agent use the environment, not your clipboard. So the builder checklist is simple. Use Kimi K2.7 or another strong open model when the base model is already closed and the price matters. Use Fireworks or a similar platform when you do not want to own the GPU stack. Build the dataset from examples you actually trust. Keep the first run small. Compare against the base model with a private eval before you celebrate, and do not fine-tune because the tutorial made it look easy. Fine-tune when you can name the repeated job and prove the custom version wins. If you want more top AI tools and workflows as they drop, join the best AI community linked in the description. I will keep breaking down what is actually worth using.